In this question, our task is to write the equation of the quadratic represented by this graph in vertex form. So let's first write what the vertex form to this thing would be. So since this is the vertex form of this thing, the idea here, the objective here, is to identify what the value of A, H, and K should be. What number should we have in those positions to get this blue graph? Now we could immediately find the values of H and K because that represents the horizontal and vertical shift. So from the origin, as you see, we're shifting this graph 5 units to the right and 3 units down. So that means that the vertex is at positive 5, negative 3. So those are going to be the values of H and K. So we have that part already filled out. And because we're adding negative 3, let me just rewrite this. I'm not going to write this as plus negative 3. I'm just going to write it as minus 3. So that's the proper form of adding a negative value. Just simply saying we're subtracting the positive number. Now the only thing pending here is this value of A. Okay, how wide is this thing going to be? Is it going to have the standard width, or is it going to be wider than normal? Well, how are we going to figure that out? Well, the way to determine what the value of A is to now to use any other point on the graph. Since I have labeled the point for us right here, I'm going to use the point 7, 1. So I'm going to let this values be the x and y value to this function, and that's going to isolate and only have the variable A be the only variable left. Now remember, f of x is the exact same thing as y. So I'm going to write this equation. Before I substitute it in, I'm going to write this equation at the following. A times x minus 5 to the second power minus 3 has to equal to the output value of y. So now we're going to substitute in the value of x with 7 and the value of y with 1. So let's substitute those values in. So we have A, 7 minus 5 to the second power minus 3 equals 1. Now to solve this equation here, we're going to begin by first simplifying this part here, this parentheses part right there. So I would subtract the 7 and the 5, which is 2, but I have to raise that value to this second power. So 2 to the second power is 4. So here's my equation. 4a minus 3 needs to equal to positive 1. So solving the equation, we'll add 3 to both sides. This is a two-step equation. We're going to first get rid of the constant. So since we're subtracting 3, we'll add 3. And we're going to end up with the value of 4. And then we're going to divide by that value of 4. And there, we found our value of A. So A does end up equaling to 1. So it has the standard width. It hasn't been vertically stretched nor dilated from any other quadratic. So our answer is this. F of x equals to 1, which doesn't have to be written, times x minus our h value, recall is 5, to the second power, plus our k value, which is negative 3. So this right here is our answer. Now if this number was not 1, we can write the 1 right there if you like. But if it's not 1, you'll definitely have to write it. But because it's 1, it's understood again that having no coefficient in the front is our invisible 1 scenario. So here is the equation for this specific graph, using yet again the vertex and the points provided for you.